All right, guys, in this video, my second video on organic chemistry, naming compounds, we're just going to look at branches. So in the course, we only need to know about 1 or 2 carbon branches, which means, you can have branches longer, especially with bigger molecules. But since we're only doing carbons 1 to 8, we really don't need to go into much more detail. The chains just don't work out so well if they're longer. So looking at this, basically, if we've got 1 carbon in a side chain, then it's a methyl group. And if you have 2 carbons, it's an ethyl group. So if we have a look here, we know that this one would be propane. And these side branches basically replace a hydrogen on the carbon chain. So this would be propane, but if instead, obviously it can't be on the ends, by the way. So there's no branching off the ends unless you have 2 carbons going like this, which you can have. So technically what I just said was wrong, but let's just think about 1 branch at a time. If I have 1 branch in the middle here, and I'm just going to make it a methyl group, so CH, okay, and then I have, actually there's rubber on this thing. Nope, there we go. I'm learning how to use my pen, guys. How good is that? Okay. So we then have 1, 2, 3. We need another hydrogen there. And we need 3 hydrogens on the end ones. Okay. So this has now got on the second carbon, this is a methyl group. This is a methyl group. So we now have it, and it's not on the end carbon, so it's not on one either there. So counting from either end, this is the second carbon. Makes it easy with propane. So this will be 2 methyl propane. Okay, and that's how we name that one. We know that the methyl group has to be on the second carbon in a propane chain. Okay, so we have a look at another one. Let's look at butane. So what if, again, we just have 1 group, hydrogen there, hydrogen there. This is a long way of writing out all the hydrogens, but to start with, I think it's really important that you don't forget where they are, because you can't start the simplified ones until you recognize how the bonding works with all these. Okay, so here again, I have my methyl group. Now, if I counted from this carbon, go backwards, 1, 2, 3, I would get that methyl on the 3rd carbon. If I name it from this end, 1, 2, it's now on the 2nd. We take the lower number. So we won't use those numbers there because they end up with a higher overall number. So again, we've got 2 methyl, but this case, we now have 2 methyl butane. Sorry, for a minute there, I just had to remember what I was doing. I was actually thinking a little bit ahead. Why haven't I put ethyl groups on these? And the reason I haven't is if this was an ethyl group, it would actually end up with being a hexane chain instead. When we do, we'll go through and practice some of those ones as well. So here we have hexane, pentane. So this is pentane. And here, let's do that ethyl group. So if I put the ethyl group here, and I'll show you where the thing is. 1, 2, 3, 4, 5, 6. It's actually going to be in hexane with a methyl side chain. So this is why, oops, can I go back? Undo, excellent. So this is why we don't tend to do them in this manner. Okay, I'll just erase those. Oops, that button. Okay, so if it was in the middle, that would be different. In fact, let's just try that. We'll do the methyl and then we'll do an ethyl group. So that carbon, let's do it on the middle one, because why not? And make that a H. So this is C, and there's 3 H's on here. I'm sorry, I draw them small to fit things in. And now, while I'm drawing it, you can think about what we'd call this one. Okay, So, do you figure out what we call it? It's on the either end, it's the same number of carbon, it's a third. So 3-methyl dash methyl pentane. Every time you have a number, there's always a dash between numbers and words. Okay, and sorry, that should be one word, by the way. Methyl pentane is one word. Now, we could do this same one, and let's look at it with an ethyl group on it. And we'll do the ethyl in the middle because otherwise it will just be a methyl on a hexane group. Okay, 5, and then we'll put 2 carbons here. Now, you can bend the carbons around as well, and this is what makes it rather interesting. We're going to do some modeling. I'm going to draw these 2 on the side there for a bit of space, which is fine. Think about what this one's going to be called. Now that it's got an ethyl group instead of a methyl group. Okay, all my hydrogens are in. This is the longest. This is also why we don't go past C8. Oh, it's so hard to draw them. There's just too many things. Okay, so in this case, we've got an ethyl group. That's our ethyl group. So on our ethyl group, it's on, again, the third carbon from either end. So it is 3, now it's 3 dash ethyl, and what was that? Pentane. Okay, and so that's the basics of branches. When you're doing it, one of the tricks is, and let's do that one I said that wouldn't work. Well, it would work, but it wouldn't be what we thought it was. So say if I did draw 5 carbons here, and then I did, off the second carbon, off either end, it doesn't matter, I did an ethyl chain. What I would end up with now, I want you to think about which chain is actually the longest. And this is where you have to be careful and you have to think about what the picture is actually showing you, or the diagram in this case. So on here, I have 1, 2, 3, 4, 5 along the bottom. And you might think, okay, so it's 5 pentane, ethyl group there, second carbon, 2 ethyl pentane. But it's not. Okay, so 2 ethyl pentane is wrong. Why is that? Because the longest chain is not the pentane chain here. If you go from the carbon on the side, what we think is a side chain, along here, that is the longest chain, and that has 6 carbons in it. So it is a hexane group with a methyl attachment. So, and the methyl is the third carbon from the end there, fourth from that end, so third is the better one. So it's 3-methyl hexane. Okay, not 2-ethyl pentane. That's wrong, because the hexane is the longer chain. So that's one of the tricks you can come across with doing these. One more thing to learn about these is when you have multiples. So multiple branches. And you name this by the carbon they're on, and you use the prefixes either di for 1, di for 2, tri for 3, and tetra for 4. When we do, we look at halocarbons, haloalkanes, you'll notice that we use the same numbering. Okay, so we just want to, firstly, how many branches of each type? So let's get one. Let's get one down the bottom here. So we first think, and then we number the carbon they are on. Okay, lowest numbering always. So let's do actually one of the easiest ones, or one of the simplest ones we can do, is a propane group. Okay, so we can actually substitute not just one. We won't do the ends because one carbon on the end just makes it a butane group, butane chain. So we're going to put one carbon up here. So we have two methyl groups in this one methyl group up there, and one methyl group down the bottom. So basically this looks like a giant cross. Okay, so with this, we would name, it doesn't matter which way you read. You could say that's your main chain, or you could say this is your main chain. There's still going to be three. So propane is our main chain, 3 carbons. So 3 carbons. And we have 2 side chains. Okay, so we have 2 methyl side chains, which means we have dimethyl. So the prefix goes on the front of the methyl or ethyl groups prefix as well. So we've got dimethyl propane. We've got to do one more thing, even though it couldn't be anything else, because we can't have any other ones. One word, sorry, it's just hard to get that balanced, is we need to write down which one they're both on. So we need a number for each of them. Either end, this is the second carbon. Okay, so we need to put a number for each of them. 2, because this one is on carbon 2, and the second one is also on carbon 2. So this is 2,2-dimethyl propane. Okay, and so it's important. So this one's on carbon 2. Even if they're on the same one, they have to 2 methyl groups on propane. Okay, so that is branches and how we would name them.